Hi, my name is Maximilian Dreyer, and I'm going to present you our Reveal to Revise paper, which proposes an explainable AI life cycle for iterative bias correction of deep models. The task we are addressing is to reveal and revise model biases. An example of such biases is shown here on the right for the skin lesion classification task. Here, there exist band-aid, ruler, and skin marking artifacts in the data. So let's begin with revealing such biases. A current limitation in literature is that there only exist a few methods. So in our R2R framework, we propose two approaches for revealing biases. One is an already established approach called spray, and the other one that we propose is to use the CRP method. So let's begin with spray. Spray, as shown here on the right, finds outliers and explanations. And hopefully, in such outliers, spurious features are used, as, for example, here shown the band-aid artifact. Alternatively, we propose to use the CRP method that allows us to study the latent representations or concepts of a neural network. And in this case, we could identify two representations that correspond to the band-aid artifact. Spray and CRP allow us to label the corresponding data samples with this artifact, which will be important for the next step. So regarding model correction, usually methods require dense labels, meaning they require segmentation masks of the artifacts. In our framework, we propose a semi-automatic way of generating such dense labels. The approach is here shown on the right. So the main idea is that we try to find a vector, a concept activation vector, in the latent representation space of the neural network that corresponds to this spurious concept. And then in the next step, we can compute a heat map for this direction that indicates which pixels in the input are responsible or corresponding to this artifact. And using this heat map, we can then crop out, for example, and extract the artifact in the input, which will be also useful not only for model correction, but also for model evaluation. So let's continue with model correction. In our framework, we include three current state-of-the-art approaches called right for right reasons, class artifact compensation, and contextual decomposition, explanation, penalization. And here the idea is to unlearn the artifact so that the model which previously used the artifact doesn't use it anymore after the correction. So let's continue to model evaluation. The current limitation in literature is that often the evaluation is only possible in controlled settings where we can insert and remove the artifact in a controlled way. However, in our framework, we propose to also do a model evaluation, but automatically using our dense labels that we computed earlier. And we propose two ways to evaluate our models. The first one is to poison the dataset, meaning that we add the artifact that we extracted previously to clean samples and then measure the performance of the model. And the second one is to compute a heat map for each sample and then measure the amount of relevance that lies on the artifact. So all these steps can now be combined into a cycle. And in principle, we can go through this cycle in multiple iterations, as is shown now in the following. Here we begin, as shown on the left, with the skin marker artifact. In the next step, we unlearn the band-aid artifact, and lastly, also the ruler artifact. And here, then shown on in the last row, we can see that using the seed maps, that the relevance on these artifacts is significantly reduced compared to the vanilla model that is shown here in the second row. Thank you very much for your attention. If you're interested in Reveal to Revise, please come and visit us at in the poster session.